Let us talk about this problem. We are given a number n. We need to print first n numbers in sorted order such that all these printed numbers have digits only as 5 or 6. So we are given a number n, say n is 10. We need to print first 10 numbers. So these are the 10 numbers. And all these numbers should have digits as 5 or 6. So the smallest such number is 5, then 6, then 55, then 56, and so on, right? If we are given 4, then we need to print first 4 numbers in increasing order. How do you solve this problem? One simple way to solve this problem is to simply run a loop, kind of infinite loop, that goes through all the numbers from 1 to infinite. For every number, it checks whether the current number has digits 5 or 6 only. If the current number has digits as 5 or 6 only, then print that number, increment the count, and if the count becomes equal to n, then stop. So that's the simple solution. And you can guess that it has very high time complexity. Say if you want to print first 10 numbers, then you will have to go till 566. You will have to run a loop that runs till 566, and you will be checking for every number whether the number has digits as 5 or 6 or not. One more problem with this solution is the value of n can be really large, and your numbers that you are traversing might not fit in, long int or long int. That's another problem. Now stop this video and think of a solution that works fast and handles large numbers. The idea of the efficient solution is to use queue data structure. We consider numbers as strings because the numbers might be really large, as we discussed. So what do? We first enqueue 5 and 6 into the queue. Then we run a loop. We one by one pop a number from the queue, and when we pop the number, we print it, and then we append 5 and 6 to this number and enqueue these 2 new numbers to the queue. That's the idea. So if you look at this approach, it works this way. You see all the number systems, they work this way. Like if you begin with the empty string, then you append 5 to it, then you append 6 to it, then you append 5 to this number, and then you append 6 to this number, 56. Then you append 5 to this number, so you get 65. Then you append 6 to this number, you get 66. Then you append 5 to this number, you get 555. Then you append 6 to this number, you get 556. Then you append 5 to this number, so you get 565. So if you see this tree, and if you do traverse the tree level by level, you get all the numbers in increasing order. So what do? We first enqueue 5 and 6 into the queue, right? That is what we've done here. We enqueue 5 and 6 into the queue. Then we run a loop, and in the loop, we pop an item one by one. So what is popped first? 5 is popped first, right? So when 5 is popped, you print it, right? So in C++, you have to call 2 functions to pop an item. You will have to call top first to get the item, and then you will have to do the pop. In Java, it can be just q.pop here. You do not need this pop in Java. Also in Java, we create a linked list this way. This is Java syntax of creating a linked list, right? This is how you create in C++. So once you have popped 5, you will append 5 and 6 to it, and you will enqueue them. So they are now in the queue. So initially your queue has 5 and 6. Then you dequeue 5. You remove 5 from the queue by calling pop operation. Then you append 55 and 56 here in these 2 lines, right? Then you run the loop again. Next time what you will get? You will get 6 from the queue. And what will you do? You will enqueue 65 and 66. That is what we have done here. 65 and 66, right? And next time when you do a pop, what will you get? You will get 55. And what will you do? You will print 55 and you will enqueue 555 and 556. Basically what you've done, you attached 5 at the end of it, enqueued the new number, attach the 6 at the end of it and queue the new number. So that is how you keep doing, and you stop when you have printed the n numbers. So this is the solution. How much is the time complexity of the solution? This is going to take big O of n time, right? If I assume that string copying and string is a constant operation, right? The number of digits in the output numbers are constant. So the time complexity of this operation is big O of n. It uses Q data structure to efficiently implement it. One more interesting fact, I mean, not only the 5-6 digit, you can solve any digit question. If you look at our decimal number system, this is how it works. You know, if you NQ 1, 2, 3 to 9 into the queue, then if you just follow this, you will have all the decimal numbers increasing order, right? You will have 1 to 9 first printed because they are first NQ'd into the queue. Then you will have, 1, 0. Then you will have 1, 1, 1, 2. You basically are attaching all the digits from 0 to 9 at the end of a number that you have just popped from the queue. So our whole number system that works in a tree fashion that we just written. So we talked about a queue-based problem where we use Q data structure to serve two purposes. We could handle the large numbers and we could print all the required numbers in increasing order in an efficient way.